Because
Yeah,
you...
with finger pants.
Oh, finger pants.
Yeah, I have them in my backpack, but I'm not going to get them out because I'm afraid Gina's going to tear them up.
This is why you're here.
So, for number one, what you would have done is you would have picked... We goot? Are we goot? Okay. You would have picked the number 28. You would have put big brackets and you would have written a 28 right here, right? Very good. Then you would have multiplied it all out. And because of time and tolerance, again, stop me if you're like, wait, what happened? That's fine. But because of time and all these things, once you did it and you pre-reduced all of those and all of that stuff, then you would have ended up with... Let's keep it colorful but different. You would have ended up with 20x minus 6 equals 1. That's what I was looking for. Okay, so we did 28, right? Over 1 times 5 over 7, yes? True? Okay, then we would have pre-reduced this guy, right? Open it up and check your own work. Open it up and check your own work.
I know that I didn't do it right because I couldn't finish it.
Then open it up and play along.
Broski.
Because if you don't put some meat in the game, you ain't never going to get anything out.
That's wet.
If you don't put some meat in the game, you're not going to get anything.
Okay, what are we going to pre-reduce? Right there. Eli, since you were the one asking about it. What were we going to pre-reduce here?
5 and 1. Or 28 and 7.
28 and 7 sounds like a good plan. What are they going to turn into?
28 is going to turn into 4.
It is, that's right.
And then the 7 is going to turn into a 1.
Yep, and then what's 4 times 5? 20, so that's where the 20 came from. Great question. Okay. So then once you did that, you would have added the 6 and ended up with 20x equals 7. Correcto. Remember to stop me if you get confused. But you should have these down theoretically if you did it. Oi, I can't answer that right now. And then you would have divided the 20 and ended up with x equals 7 over 20. So that's where we should have ended up on this problem. Any questions before I move on to number 2? You got to strip your mental cap on, buddy. You got to. Or else you're never going to get it. True facts. All right, so for number 2, what you should have done is you should have put a bracket, and when you put the brackets, you should have written the number 50. Okay? So when you after you wrote the number 50, you should have walked on down the way, and I heard a what? Do we have is there a confusion on that? Do we need to stop and say why it's 50?
Yes.
Okay, great. Good job. Virtual high five. Too slow. Slapped you in the face. Now, how did we get 50? So we're trying to find the least common denominator between 5 and 10 and 25, right? That's a good thought. That's an absolutely good thought. So let's list the multiples of 10. What's 10 times 2? 20. What's 10 times 3? 30. Oh, we've already gone past without being 25. So it can't be 25. So let's see if we can get some factors of 25. What's 25 times 2? 50. Okay, so let's stop there for a minute. And let's go back to our 10. So what will be the next factor on 10s? 40 and then 50. Okay, so that works. Now can we get 5 times something equals 50? 5 times what equals 50? 10. 5 times 10, right? Right? It's okay. You're great. So 50 works. But 25 doesn't work because of the 10. Make sense? Good. Good. All right. So after you did that and you distributed or you pre-reduced, you should have ended up with negative, what'd that be? That would be negative 80y minus 10 equals 2. Unless I'm mistaken, which I definitely could be. That's where we should have ended up. What?
I don't think you're mistaken.
You don't think I'm mistaken? Okay. So, after you did that, we should have added 10 and ended up with negative 80y equals 12. All right. And then after we did that, we should have ended up with y equals negative 12 over 80. And then we can't leave that because we can reduce that. So there's a couple of different routes you could have taken, but let's kind of make some assumptions. You might have reduced it at that point to y equals negative 6 over 40. That might have been the way you went. We can't leave that, so you might have gone a little bit further and reduced that to y equals negative 3 over 20, which is where you should have stopped.
I got 6 over 10.
Did you get 12 over 80?
6 and 1/10.
You got 6 and what?
6 and 1/10.
Okay. Did you get to this part right here? Okay. So 12 over 80 is where you're starting with. Okay, so what did you do next? Okay, so it would be a mixed number if I think you flipped it. Did you do 12 divided into 80? Is that what you did? Yeah. So the 12 is on the top. So it's not a mixed number if the littler number is on the top. So then we're just reducing. So what I did to get to these steps is I divided this one by 2. And that's how I got 6 over 40. And then I did that, and then I divided them by 2 again, which is how I got 3 over 20. Does that make sense? So you just accidentally flipped the fraction over. Magical fraction flipper. Try to say that 10 times fast. Magical fraction flipper. I don't think I can even say it one time fast.
Magical fraction flipper?
You did it. You even have braces and such. You're so talented. See, it's hard. Exactly. All right. So, any other questions on number 2 before we look at number 3? Kiddos. Any other questions on number 2 before we go to number 3? Ella says no. No. Ella's got some pretty earrings on today. Okay, let's see. So for this guy, what you should have done is you should have put a... Are we here? Are we good? Are we goot? So you should have opened up a big bracket, and outside the bracket, you should have written the number 18.
You sound like one of those tutorials.
Number 9. Okay. And then after you did that, once you distributed that 18 out, and then you pre-reduced and multiplied, you should have ended up with 12 plus 4 equals 4x. I did. Someday, you will be able to as well. I'll guarantee it.
I feel like
Okay.
I'm not good enough at math.
Not yet. Not yet.
Someday.
Okay. So after you did that, you should have added the 12 and 4 and gotten 16. So you ended up with 16 equals 4x. And then you should have divided the 4 off and flipped it around. It ended up with x equals 4.
The first time I did this, I forgot to write x, so I was doing out that one until at the end I just
Like
got
what?
16 equals 4.
And like, that's not true.
I was like, you forgot.
There will be problems someday. Someday, quite soonish, maybe. Well,
Quite soonish, maybe.
Yeah, I was trying to think if we ever do anything like that in pre-algebra. You definitely do it in Algebra 1, but I don't remember if it exists in pre-algebra. But at some point, whether it's in pre-algebra or in Algebra 1, you will have a problem where the variable goes poof. And then you have to decide what to do now. So that will happen, but not yet.
Is there any way you could, like, is there a possible way you could get like 2 answers out of them?
Yes, there are, actually. There absolutely are.
But how do you what do you do to get x equals 4?
X equals 4 part? Okay. Yeah. So you got to this part?
Yeah.
Okay. So we'll pick it up from there. So 16 equals 4x. So what's attached to x? How's it attached? And we do the opposite to get rid of it. So what is attached to x right now? 4. How's it attached? So we do the opposite to get rid of it. So what's the opposite of multiplication? Division. So we're going to divide 4 on both sides. What's 16 divided by 4? 4. So that's where the 4 comes from. Now, because we're trying to get into a good habit, if we end up with the variable on the right side, the last thing we want to do is to just switch these two around. And so we end up with x equals 4.
But how do you know if you don't do like plus or minus 4 on both sides? You just add.
If you, okay, say that again.
Like when you get to 12 plus 4 equals 4x, how do you know you just add 12 and 4?
Because okay, let me see if I can answer that question well. Al, you two, I need one of you to move.
Yes, sir.
You can move over there with her, or you can move over here. But one of you move. I don't care which, because it's not helpful to either one or both or something, and it's not doing good. So let's have one of you move. It's not that I'm worried about talking. I just need focusing. It needs to happen. I'm not mad, just helpful. Okay, so answering this question. So how do we know that we just add 12 plus 4 instead of putting it to the other side, right? Is that basically what you're asking? Okay, so if you just saw this on the page, what would you do with it? Just add it. But if you saw this on the page, could you just add it now? No, because they don't go together, because they're not like terms, right? So if they are like terms, you can just add them and put them together.
So like if the x is on the other side of the equal, is that when you would just add?
Sure. Well, it's not just because of that either. Like, we haven't seen problems like this, but if we had something like this, like say we had 2 plus 8 minus 3x equals 7. These two, we could just add, because they can go together. But not with this one. Does that make sense? So like if we were to solve this problem, it would end up being 10 minus 3x equals 7. And then we would solve it just like normal, right? So we would subtract the 10 and then divide by the negative 3. Does that make sense? Does that help kind of, sort of?
Then why would you do minus 8?
Because we could have on this particular problem, actually, I mean, we could have done it that way. We could have, if we started with 2 plus 8 minus 3x equals 7. On this particular problem, we could have subtracted 2 and subtracted 2. The reason why we wouldn't want to do that on this one, so this is where we were on this problem, which is where the question started, well, No, we were at this. 12 plus 4 equals 4x, right? Okay, so we could have. Remember, with equations, you can pretty much do anything you want as long as it's legal. So we could have subtracted 12 from both sides. We could have started this way. This would have canceled, right? And we would have ended up with 4 equals 4x minus 12. We can't put those together. Why not? Because there's an x on one. So we would have had to just write it down next to it. So you could have done that. It just wouldn't have necessarily helped you get there quicker. Because the next thing that you would have had to do, and watch this, this is gonna blow your mind. The next thing we would have done to solve this, right, would be to add 12 to both sides, right? And it does go with that one, right, because it doesn't have an x. So these ones would cancel, and you end up with exactly what we ended up with by just adding them in a circle, kind of. Mm-hmm.
Wait, then why did you go backwards?
Well, because our ultimate goal is to get the stuff off of the x, right? That's our goal, right? And so we just, by adding 12 over here, we're putting something on x. So basically we were being supervillains, adding bad guys to the problem. How dare we?
Why couldn't you do +4 side?
You could. Well, you'd have to do minus, right? Because it's positive, right? You could do it that way instead. But then the thing that you would have to immediately do is subtract it back off again. It'd be the exact same as the 12, but with 4. So you can do that. It's just on this particular problem, it would be slower. Like, let's because I feel like this is a useful conversation, believe it or not. Let's build a problem together, shall we? I want everybody playing along, everybody writing down. And we're gonna once you see what I'm doing, then we're gonna have everybody adding to the problem too. We're gonna make an ugly problem. Are y'all ready?
It's probably going to
So.
include 72.
I know that it's probably, well, I don't know, but I figure it's going to have the number 72 in it somewhere. What do y'all want to bet? And a cookie?
For Eli.
No, it's not going to have a cookie because we're going to keep X because we're going to keep that kind of simple-ish. All right? So, we're going to start with X equals 5. How about? There's our beginning. So we're starting with the answer, and we're going to turn it into an ugly problem. Okay.
You should have done x equals 72.
No, I was waiting and letting you add the 72 in later. See, smart. Okay, so the first thing we're going to do is we're going to add 50. If we add 50 to this side of the equals, what do we have to do to the other side? Add 50. So now we have these two. Do these two combine? Yes or no? These ones right here. No, right? So on this side, we have 50 plus x equals, do these two combine? Yeah, they do. 55.
But where did you get the 50?
I made it up. That's what we're doing right now. We're making stuff up. We're making it up. You're going to do it too in a minute. Okay. Here's the next question. There are two black lines. There's the line 1 in black and there's the line 2 in black. Those two are equivalent. They are the same thing.
What are?
X equals 5 and 50 plus x equals 55 are the same thing. You could prove it by solving this one for x. if you were to solve this one for x, what would you do? Minus 50 on both sides. And you would end up back at the beginning. All right, so now we're going to add something else. Are you ready? So, what we're going to do now, let's try to keep something with numbers that are useful. What we're going to do now is I'm going to take and I'm going to divide this side by 5. If I divide that side by 5, what do I have to do to the other side? Divide by 5. Now, with division, it's important to know that you have to do everything by that. So this by 5 and this by 5.
But if the adding sign and the x,
I'm not trying to solve for x. I'm trying to make x a terrible thing. We started with the answer. We know what the answer is.
So the answer to that is still x equals 5?
Yes. So let's write down.
Wait,
Excuse me.
why did you write divide by 5 on the x?
Okay, so here's why. Let me. This is kind of a little bit brain bendy and a little bit beyond what we're typically doing right now, which is fine. If I did, let's see, let's do something with a common denominator. If I did 3/5 plus 2/5, what would I do with that?
You make it 1 and 2.
Do what? Add the 3 and the 2 and put that over 5, which would turn into 1, right? So if I was to write that out, all the steps, right? It would be like this, right? 3 plus 2 over 5, right? And which would be 5 over 5, which would be 1, right? So the reason why we do this is because if we divide everything by 5, it's kind of like dividing, or it's the same as dividing each one of them by 5. So we have to divide everything by 5 when we do divide both sides. I don't know if that helps or not, but that's why.
why are we doing this? We don't know the answer.
No, we don't know the answer because the answer to this is the problem which we are creating, and we are making it ugly. And the point of what we're doing is we are proving that you can do anything to a problem as long as it's legal, and it's going to come out the same.
I thought you said lethal.
Legal. So if we're going to clean this guy up, what's 50 divided by 5? 10. Plus x over 5, we can't do anything with, right? So just x over 5 equals, what's 55 divided by 5?
11.
It is 11. All right, Brooklyn. What do you want to do to this now? You can say add blank, divide blank, multiply blank, subtract blank, whatever else. Pick something. It doesn't have to be pretty. It can be ugly. Multiply what? It's a specific number. I want whatever you want. 11. Sounds great. Multiply 11. Okay, so we're going to multiply 11 on this side. If we multiply 11 on this side, we've got to multiply 11 on this side. Now this one's tricky. We're going a little bit beyond here. No, you're not going to have any homework on this. I know you, Ella. I know what you're going to ask. No, we are doing a mental exercise that is useful. Why have you written nothing down? I want everybody playing along. I did say that at the beginning. True facts. Now, this one's a little tricky. This one, just trust me on this. You're not going to have to actually do this until partway through your next class. Or maybe your next class, depending on what you take next. Okay? If we do 11 times all this, what we have to do is something called distributing it. Okay? So we're going to distribute this guy to both of these things, which means we're going to multiply it both places. Okay? So we need to do 11 times 10. What's 11 times 10? It is 110. It is. Now, 11 times x over 5 is 11 times x over 5, right?
But why are we doing this if we're going to have it for homework in the next class?
You're not ever going to have a problem just like this for homework. Never, ever. We are doing this to cement the ideas and the skills in your brain. We're doing this for a purpose. I am going to give you homework, but it's not going to be like this. It's going to be like your last 2 or 3 homeworks. It's going to be more of the same. I am absolutely going to give you homework. It's just not going to look like this.
You mean the next, like.
Okay. What's 11 times 11? 121. All right, Eli. What do you want to do to this now? You can say add, subtract, multiply, or divide, and then you have to say a number after that. It can be positive or negative. It can be anything. Divide by 120. Sounds great.
That's not 72, Eli.
Well,
We're waiting for
you're
you to
giving
do
you
it.
the opportunity to 72 up the problem.
So, divide this side by 120. We've got to divide this side by 120, which is the side. Now, this one is going to be a little tricky on this one. Let's see if we can think through this one in a minute. What have you done, Eli?
What did I do?
Y'all strap in for the ride and have some fun. We're having fun today. We're having fun with math.
Math.
Okay, this one's easy to simplify. Good job for making an easy thing to simplify, Eli. We're so proud. And then good job for making whatever that mess is. Okay. If we have zeros at the end of a fraction, do y'all remember what we can do with those? We can just delete them. I don't know who said that, but I like that verbiage. The zeros can just go away. So that reduces to 11/12, right? Oops. That's not 11. That is.
How far are we gonna go?
Till we get to Asher.
Out of space.
We've literally gone.
Wait till you have a real problem that takes up a whole page.
I've already had multiple.
That will happen.
And it's gonna be great. It'll be the best.
It will be the best. Y'all want to see one? Y'all want to see a big old problem?
I think we're about
I'm going to show you a big old problem. Since today we're apparently just having fun with math. That sounds great.
When I did homeschool math with my mom, she would.
That's kind of what you're doing right now. It's homeschool math, but
my
I
mom.
understand.
You're not my mom.
My mom.
I am not your mom.
My mom.
Have y'all ever read the book? Are you my mother?
I have. My mom.
That's a hilarious book. You know what?
She got me a math book at Barnes and Nobles and said, "Here, do it." And then
Very good.
And then that's how my math died. And then that's how that's why I couldn't do math for like a year because the book sucked.
There's a problem right there. Someday you'll know how to do that problem.
That's so
I'm
emotional
excited
damage.
That right there is math.
That right there is emotional damage.
That's pre-calculus.
That's what my.
Honestly, calculus in a lot of ways, at least Cal 1 anyway, is easier than pre-cal.
Wait, so is.
As long as you know algebra really well.
What grade do you do pre-cal in?
It depends. Often it is in your junior or your senior year.
My senior at a school, and he hates pre-calculus so much.
So much. Well, that's fine. He's allowed to hate.
I remember when I was in
Pre-cal has got some hard stuff in it, and then it's got some other stuff that's not so hard. Kind of like a lot of math classes.
when I was in third grade, my fifth grade cousin was like,
This problem is not particularly hard. The problem that we did before this, let's see if I still have it on one of these layers. I bet I do. This problem was stupid,
yeah, but fifth grade math was easy.
and I accidentally had us do it. Because this problem, that's the answer. Look at that ugliness.
C equals negative 1,126.
Yeah.
Did you just do that for fun?
No, that was.
That's not a for fun thing.
It is kind of fun, honestly. I like solving systems this way. I think it's kind of fun. It's not my favorite way to solve systems, but it is fun. Geometry is the best because geometry is a bunch of puzzles. Lots and lots. Look at these problems. Let's see, what else did we want to see today? That's your future.
Geometry.
Look at that. That's an algebra 2 problem.
That was cool.
That's algebra 2.
Yeah, yeah.
What does algebra use?
Let's see. What were we doing in algebra 1? This is algebra 1 right now.
Fun class 78. That one didn't look too bad.
Yeah, I mean, that one looks even worse. Wait, does that mean is that all one problem or?
That is several different problems.
Oh,
Yeah,
okay.
that doesn't look that bad.
This right here is all one problem. That's probably the hardest problem on this page. It's honestly, I will tell. This is gonna shock you. You ready? I could teach you people in this room how to solve that problem. Because in order to solve that problem, you only have to know how to do 3 things. You have to know how to multiply, you have to know how to add, and you have to know how to subtract. If you can do those 3 things, you can solve that problem.
And I hate to break it to you, but that's not the alphabet. A, B, C, C.
Oh yeah.
I hate to break it to you,
Yeah.
but like, sorry to burst your bubble.
Sorry to burst your bubbles. And did you know that if you raise cat to the 0, it equals 1?
What's the hardest?
What else do we want to look at? Let's see.
What's the hardest problem on here?
I don't know.
The craziest.
There's a little bit of geometry right there.
Oh, my emotional damage.
You end up writing a lot in geometry. It's a lot of writing in geometry.
Handwriting.
It's kite. Mr. Kite.
It is a kite.
Well, if you're writing in geometry, then how is your handwriting so weird on whiteboard? And also just.
Are you crying right now? Big crybaby. Crybaby.
Oh, I'm sorry, Michael Jackson.
I can move on pretty good, so I
This is really hard. Oh wait, this is y'all's math.
It's not really hard. It is. Well, I mean, it's not.
Here's y'all want some encouragement? Would y'all like some encouragement? The way I'm teaching you how to solve problems, these problems in particular, there is nobody else. That's probably a slight hyperbole, but there is basically nobody else in your grade who is solving problems this way, and you're doing fine at it.
That means that everybody else knows some different, easier way to do it? Or
No.
way to do it?
A different way to do it.
Are we doing it easier or
You're doing a way that has more far-reaching, useful skills
like
with it.
the way will stay the same. You don't have to learn different modes.
Exactly. Exactly.
It's kind of off topic, but did you grade our quizzes?
I did not hit. Sorry. All right. So let's see. We opened up a bunch of stuff. Where were we in our actual thing? Where is it? Is this it? This is it. Okay. So.
72.
All right. So what we were dealing with, we're gonna have to put a pin in this at some point because I'm gonna have to give you some homework because I have to. So I don't think we're gonna quite make it all the way to Asher today. So we're gonna have to wait, and we're gonna have to make it all the way to Asher on Monday.
No, 72.
Sorry,
72 is gonna have to wait, but we're gonna play with this problem a little bit more.
Why did you do that to me?
All right, let's see if we can figure this guy out.
Why did you play with my emotions?
See, one of the reasons why we're doing this, even though we've tossed in some things that are a little bit weird and a little bit different than what we've seen, have we done anything, just like as far as the math part, the arithmetic part, have we done anything that you didn't know how to do on this ugliness? No, we haven't. We've added some things like you didn't know what distributive property is, right? And you don't have to know that, and that's okay. But you knew how to multiply 11 times 11, didn't you? And you knew how to multiply 11 times 10, right? Right. So that's another part of the point of what we're playing with today. And I want to emphasize yet again that that's what we're doing right now, is we are playing with this problem. We are not doing something that you are going to be responsible for on a quiz. Calmate.
Are we gonna finish this problem today?
Well, there is no end to this problem. But we are going to stop doing this problem today, and then we're going to pick it up and do a little bit more on it on Monday.
Maybe depends, are we going to find the beginning of this problem today?
We definitely won't undo what we've done today. We're not going to get that far because we're not going to get to the end of this part. But then on Monday, we're going to take everything we did and we're going to undo it. And we're going to end up back with x equals 5.
But we already know the answer.
The answer is the problem, which is very important.
You're getting a little bit
In math.
too soon for me. The answer is the problem.
In math, and this is really important, a lot of times we get confused, and I understand why. It's because of grading, and it's because of these other things. We get confused about the difference between finding the quote unquote answer and learning how to do the skill. Because what you're trying to do right now is learn how to do the skill. You're going to make mistakes. I hate to break it to you, but even I make mistakes. I know you're astonished, right? Mistakes will happen. Just because you make mistakes doesn't mean you don't understand. Follow me? Okay. So the skill is important, which is what we're playing with today. Now, so we are going to at the very least figure out what the heck to do with this mess. So I'm going to bring him over here. So we've got 11x.
But if this problem is eternal, then
Is it because I wrote 100?
how do you know the answer is 5? If it's never ending, how do you know the answer is 5?
Because we know where we started. It's actually kind of the root of a like graduate level math class called chaos theory, but extreme sensitivity to initial conditions.
You didn't say words.
Okay, we need to figure out how to deal with that. So here's how we're going to deal with it. You ready? It's easier than it looks. What is division the same as? No, it's the opposite of multiplication. It says division is the same as what? Not subtraction. Not addition. Division is the same as division. Fractions. Division is the same as fractions. True facts. So, what's 4 divided by 2? No, it's not a squeeze me. It is 2, though. What's 4 times 1/2?
Are we supposed to write this down?
This one I wouldn't. The one up above I would. It is 2. Right? If we wanted to walk it through the way we've been doing it, we would pre-reduce, right? And turn this into a 2 and this into a 1. 4 times 1/2 is the same as 4 divided by 2, right? Makes sense? Okay. So, this works the same way. 11x over 5 is the same over, or over 120 is the same as that times 1 over 120.
What if we just changed 120 to 72?
We can't just change it. That's not legal. I said we can do anything as long as it's legal, and that's not legal. In math, we can't just change things. There has to be balance. Balance is very important to math.
It's also important to the force.
Yeah, but then they break their internal consistency. So, can we pre-reduce this pink thing any? Does 11 go into 120? Yes. Unfortunately, it does not. Because 11 does go into 121. And since it goes into 121, it don't go into 120. So we got to multiply 5 times 120. So y'all scratch paper that for me real quick. Or do it in your head, because that one's actually not bad if you know your 12s. No, not 520. 600. I don't know why you did either. Okay. So this turns into 11x over 600.
I just wanted to add 10.
Is that the answer?
That's the answer to this part.
What? There's no answer. There will never be an answer.
There is an answer. This is the answer. This doesn't reduce either. We just went over that. So 121 over 120. Later, not today, but later we're going to prove that all of this is the same as x equals 5.
I'm annoyed if I did this whole problem and then it just ended up being x equals 5.
All right. We're going to do one more, and then I'm going to give you some homework. So, Ella,
These big ones?
what do we want to do to this now? You can add, subtract, multiply it, and here's the deal. As of this point, if you want to choose letters, you may. Or you can pick numbers.
Or cookie?
Because 72 is very negative. All right, Ella, what are we gonna put on this thing now? What? It already has a letter, but if we want to add another one, we can. Or the same one. Whatever you want. It doesn't have to be a letter, but it can be.
18.
What? You could pick E. So what do you want to do with an E? Do you want to add, subtract, multiply, or divide it?
E for X scared.
Or E for Ella?
Subtract E. Okay. Believe it or not, that's going to be easier than the step we did previously.
Is there a limit to how many letters can be in one problem?
No. So I'm going to, in order to do this easier, I'm going to scooch this over because it's going to make my life a little bit easier. So 121 over 120. And we said adding E, is that what you said? Okay. So, subtracting E. So we're going to do minus E. If we do minus E to that side, what do we have to do to the other side? Minus E. That E can't combine with anything else because nothing else has an E on it. So when we simplify this, it's 11 twelfths plus 11x over 600 minus E equals 121 over 120 minus E. And that's as simple as it gets so far.
But why?
Because that's what she wanted to do. So, it's only 11:05, so I think I lied to you, and we're going to do one more thing. Olive, what do you want to do to this problem?
Solve it, probably.
Add, subtract, multiply, or divide anything. Add 1 million. Okay. 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 So we're going to add 1 million,
Yeah, I love it. I love
which for those of you playing along at home is a 1 with 6 zeros on it.
I love some good anger.
Now, the trick with adding 1 million is it'll actually combine with this one
What?
because
Oh no.
this one doesn't have an X on it. It will also combine
Change it.
with this one because it doesn't have an X or an E or anything else on it.
What has begun?
What are we doing?
So we're adding 1 million to 11 twelfths, which is actually easier than it sounds. Let's take a look at it. You ready? I did say we should play, and this sounds like play to me.
No.
This is great. I have never enjoyed math more.
Well, good. 11 twelfths plus 1 million. In order to add those two things, what do they have to have? A common denominator. So what do we have to multiply times 1 million? 12. 12 over 12. Now that's really easy. Any one of you can do that in your brain. No, stop and think. What's 1 million times 12?
12 million.
12 million.
12 gazillion billion.
Okay. So we end up with 11 twelfths plus 12 million. That's 12 with 6 zeros. Over 12. Because it's fun, dude. Because it's fun. Embrace the lunacy of the fun math. Embrace it, I say. You're going to do it and you're going to like it. What's 12 million plus 11? 12 million. I told you it was pretty easy. So over here.
Wow.
Hello.
This is already taking up one whole page.
Dang it, I lost.
Oh, we're probably going to go to 2 pages. It's probably going to happen.
This is lovely.
It really is. It's so much fun. So over here we have 12 million. 1 to 3 and 11 over 12 plus 11x over 600 minus e equals. Now we got to deal with this right side.
Wait, so it's
121 over 120 plus 1 million.
Wait, what?
We're adding these guys. Oh, okay. Okay, you're just like, I think what you mean is, wait, why? No. Okay, in order to add those two numbers together, what do we need?
common denominator.
Common denominator. What are we going to have to multiply times 1 million? Not 120. No, not yet. We're not there yet. We're getting there. But you can't say it if you don't write it down.
8072.
120 over 120. What's 120 times 1 million? 120 million.
And 11.
And 121, actually. Because we're on a different line now.
Why?
Because we're at a different part. 121 over 120 plus 120 million over 120. What's 120 million plus 121? Yep.
Wait, now is it 120 billion?
No, it's not 120 billion. It's 120 million plus 100 plus 121.
Fifth.
So we have
So annoying.
120 million. 121 over 120 minus E. And later in this saga, but not today, because we need to assign some homework.
In the saga? Is that what you said?
Later in the saga, we're going to prove to all the naysayers out there that all of that is the same as x equals 5.
What if this was just our homework? If this was our
Yeah, solve this. Actually, it would be easier than you think because you already know how to do it because you just undo all the things you did to get here.
And you just write down.
I just write the answer.
Yeah, you just write.
Like, I already know. But the problem is the answer, not the answer. Okay, so let's give you some homework. We're having fun.
It doesn't make
You're going to do it and you're going to like it.
You're the only person not having fun.
It doesn't make sense.
Because you didn't write anything. Okay.
Maybe you're not having fun because it makes sense.
Maybe, yeah.
Okay.
We can go maybe all day.
Homework.
Landing was fake. Maybe the earth is flat.
We have proof that it's smaller.
Some people believe that proof is fabricated.
What?
It's a trust issue.
I mean, it's not helped by the fact we haven't gone back to the moon since the 70s.
We have a what?
It doesn't help that we haven't been back to the moon since the 70s.
No, that doesn't help.
I mean, I don't believe that the moon landing was fake, but like, my dad.
Number 1.
How many go we have?
Yes. 3/5 y minus 2/3 equals.
That scared me so bad, and I don't know why.
I guess I have to be nice. I guess I have to do something like
72.
Can we do cookie on
6/15.
Can we do cookie on one of them?
Y'all made fun of my cookie. I'm not doing cookies ever again. Y'all are so rude. Y'all made fun of my cookie. You said it doesn't look like a cookie. We can do a cake. You can pretend like it's a carrot cake.
Can we do one of them with a brownie?
No,
How would you draw a
that's racist. No,
That's racist?
it's braces. What?
What did you say?
racist?
I was being silly.
Well, okay.
Negative 16. Let's do a one stupid problem since we're having fun with math. Negative 16/4 minus
Can we do one with tiramisu?
28/7 times cake.
Yay!
It kind of looks like a marshmallow.
Don't make fun of me. He'll never do anything fun again.
Equals
Mine just looks like a head with hair.
I'm making a layer cake.
negative 6/3. That is a stupid problem, but it's fun. It's actually a really easy problem if you stop and think for. Don't give away the secrets. Number 3,
You like my cake?
2/9.
It's a layer.
Ninths
I'm gonna vandalize you.
minus. I'm not going to draw a whole layered cake thing. No. Not happening. Minus
He'll never do anything fun again. Leave him alone.
4
A pie.
4 over pi. 1 point.
18ths
A lemon meringue.
L
Like for losing.
equals 3/3. 4.
Can we do one homework with like
2/5 minus 1.
Competition.
How many are we gonna have?
Yes. 7th
My favorite number.
equals 6/35 P. And that's it.
I told you.
Do your homework. Come back with questions if you have them. You ought to be getting fairly good at these, or at least passable if you're trying. But at least passable. In other words, even if you're not doing good, you ought to be at least starting to kind of get some of it at the very least.